Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to talk about the areas and volumes of similar solids. So when you increase the dimensions by a certain factor, what does that do to the surface area? What does that do to the volume? All right. This problem here will give you a good idea what's happening if you just read it and figure it out. Go ahead and do that, and I'll get back to you. So here's what you get for the volumes, and you might notice that the middle layer is 8 times the top layer, and the bottom layer is 8 times the middle layer in volume. So if the scale factor is 1 to 2, the volume factor is 1 to 8. And well, the one way we can figure that out is for every dimension that we double, we have to multiply to get, since we're three-dimensional in volume, to get the volume factor. And the surface area factor is just like our area factor that we learned before. Surface area factor will be the scale factor squared. All right, so we're going to use those ideas today to do some problems. First of all, this only works if the prisms are similar. So we're going to look at these and see if they're similar. So just look at the dimensions. This is 3 to 4. This is 8 to 10 or 4 to 5. Those aren't similar. This dimension is, we have 10 to 15, 4 to 6, and 6 to 9. All of those simplified to 2/3. These are similar. And the scale factor is 2 to 3, the small to the big. All right, so why don't you do this one and see what you think. If they're similar, find the scale factor. So yeah, I'd say they're similar because both the radius and the height have the same scale factor when you simplify it. Remember, there's another way to show our scale factor too, using a colon. That's the way we're going to do it when we do our practice problems. All right, so here's the relationships put into words. So if A to B is your scale factor, then A squared to B squared is your surface area factor. Let's call that. And then A cubed to B cubed would be your volume factor. All right. So here we have, we're given two volumes and we want to turn that into the scale factor. Well, if our scale factor is A to B, then our volume factor is A cubed to B cubed. And that's equal to 3375 over 1728. So A would equal the cube root of that. And hopefully those are perfect cubes. Remember that when you're doing a ratio with roots, you can separate those. So you can do the cube root of 3375 separately over the cube root of 728. And on your calculator, you have to press the math button to find that cube root. And you should have got 15 over 12. I forgot a 1 when I did this, in case you were following along really closely. All right, so go ahead and try this. So the scale factor of two similar prisms with surface areas, remember surface areas are the scale factors squared. And here's what I got for that one. All right, so we're going to use that scale factor to help us do a problem relating similar solids a little quicker. So it says here's the volumes, 40 and 135. If the surface area of the smaller solid is 48, what is the surface area of the larger solid? So what we're going to do is we're going to take this and turn it into a ratio, 40 over 135. Let's simplify that as much as we can. I know that 5 will go into 48 times and 5 will go into 135 27 times. Now if we do the cube root, so this is the volume factor. To get the scale factor, we're going to do the cube root of those. And those are both perfect cubes, which works out nice, 2 over 3. But we want the surface area, so the surface area factor, let's call that SAF. Surface area factor is those numbers squared. So 2 squared over 3 squared, which is 4 to 9. So that's what we want to use when we find the answer to this problem. The ratio of the surface areas will be 4 to 9. The surface area of the smaller is 48. And so then I'm just going to run that through my calculator. And I get 108 square inches for the larger solid. All right, go ahead, you try and do that. You can check back with my work and see if you did it right. All right, here's what I got with that one. Okay, likewise, we can do capacities and weights by using our scale factor, surface area factor, volume factor idea. So check this out. So let's say a small box holds about 220 paper clips. The large box is formed by doubling the dimensions of the small box. So we don't even really need to know what they are, but we know they're all doubled. So the scale factor is 1 to 2, since they're doubled. The volume, which would be the capacity, the volume factor would be 1 cubed to 2 cubed, which is 1 to 8. So basically it's going to hold 8 times as many paper clips. Now you could write a proportion if you wanted to do that. It would be 1 over 8 equals 220 over x. Or you could just multiply 220 times 8, since it's going to hold 8 times as many. And I think that's 1,760. All right. So you want to try one of those? Go ahead. And if you did that right, you were thinking that it would weigh 4.05 pounds. All right. Looks like you're ready to try some practice here. Good luck, and we'll talk to you soon.